Hi, I'm Rick from Marine Models, a DJI dealer from the UK. In this video we're going to be covering setting up the new Naza Lite flight controller in the Naza Assistant software. Now this is a follow-on video from my earlier how to build the E300 propulsion F450 flame wheel. So in this one we're going to cover after you've built the flame wheel, installed the radio, and basically you're ready to set it up. So the first thing you need to do is go to the DJI website, find the Naza Lite flight controller, click on the downloads tab, and then scroll down to where you see assistant software and download the assistant software, but also download the DJI WinDriver installer. A lot of people that have problems with connectivity between their computer and their flight controller is always because they haven't downloaded the separate installer software. Now the next thing you need to do is to plug in your flight controller. Now all flight controllers are supplied with a USB lead like this one. So simply plug it into your PC, switch on your flight controller. Now remember, always remove your props. Don't do any kind of maintenance or inspection indoors, or even if you only have your props on if you're about to fly, as you never know. And then just plug in the flight controller and then you'll get a solid green light. I don't know if you can see that. And that means you're connected up to the flight controller. If it's not properly connected, and I touched earlier on the Naza Assistant installer driver, sometimes this light is a very sort of dim light. So what you're looking for is a nice bright green light. So obviously plug your flight controller in, and of course have your radio turned on as well. Now open up the software and you'll be greeted with the sort of overall viewing screen. This screen just incorporates all the different parts of the assistant software all in one. Okay, the first thing we need to do is set up the radio. So if you click on the basic tab, you get greeted with this radio screen. Now there are various types of receivers for the radio, but the two that you'll be using is either the D bus, that's if you're using DJI's own DT7 radio, it uses the D bus, or if you're using the Fataba with the S bus connectivity, that also uses it. However, if you've got a traditional receiver plugged in with the multiple connections into the flight controller, you would have it clicked on traditional. You'll know if you've got it on the wrong one, because when I move the transmitter sticks like this, you'll see all the little cursors moving. Basically they would not move. So the first thing we need to do is we need to check that the sticks are throwing in the correct direction. So the easiest way to check that is if you basically pull both sticks down to the bottom left hand corner, all the little cursors should actually be across on the left hand side. So you'll notice the middle two aren't. So all you need to do is reverse, reverse, so they're now norm, and then when I go bottom left, they're all across to the left. Now what you can also do here is, this is the calibration. Now in my earlier video on calibrating the radio, you calibrate the transmitter. This is only on the DT7. You calibrate the radio in the specific RC Assistant software. But of course, presuming that's all done, or if you have your own radio, a third-party radio, presume it's all calibrated. Now you're just basically going to calibrate the flight controller and tell it that this is the radio you're using and this is how the sticks work. So the first thing you need to do is just to click on the start button there, and then twiddle the sticks in a circular motion all the way around. Now if you've got the DT7 with the trimmer lever on the back, you also need to basically go all the way back and forth with that as well, and then click finish. Click on OK, then that's that done. Now you can also see as well, as you see the cursor here, when I flick the GPS mode, you'll also see that moving as well. So you've got GPS, attitude mode and manual mode. So basically full-blown stability, so you'll have position hold, height hold, and then here you'll have attitude mode, which keeps the height, keeps the model level, So if you bank it over, it will always come back to level, but it will not hold its position where it is in the sky. So this is a good mode to have if you're going to be using it for aerial videoing, where you want a more sort of panning shot, because normally what would happen if you had input control and you were flying along and you let go, suddenly the model would just like pull its handbrake on and stop, which is great for beginners, great for holding your position, but if you're doing videography it's not so good, so you can flick it into attitude mode. And then the last one, manual mode. Now, basically manual mode is like flying a collective pitch helicopter. Absolutely no stability program whatsoever, so it won't keep its position in the air, it won't right itself back to center, it also won't keep the height. So if you bank it over, it would stay banked. So that basically makes it fully aerobatic. So only be in that mode if you really know what you're doing. Okay, the next one we're going to look at is the actual aircraft type. Now, it defaults to what we call the quadcopter, which is what an F450 is. But if you were flying like an F550 flame wheel, you could be flying this type here. So it tells you over here what all the motor rotations, so you can check what directions your motor should be rotating in. That's obviously very important. But as we're flying the quadcopter, we're basically just going to stick to this one, so you can basically see what it's saying is this motor here should rotate that way, and this motor would rotate that way, and so on. So you'll know if all your propellers are going in the right direction. Now the next one we're going to move on to is going to be the mounting of the GPS puck. So what you need to do in this one, what you're doing is you're going to be telling, if I just remove the battery, you have your flight controller under there, and you're going to be telling the flight controller in relation to its center, which is the middle of the model, where the GPS puck is. So you need to tell it it's so far that way, so far that way, and then so far up this way. And this is what these values down here are you're telling. Now the way that DJI does it is the red direction is a positive and the green direction is a negative. So for example, when you're telling X there, X is from the center point backwards. So the first one's going to be a minus. So that, as I've already measured them, is going to be -5. Next one down is 3, and lastly -13. So if you have your GPS puck mounted in the exact position as I have, then these will be the values that you would use. And then once you've done it, just press the return, and these will all go from red to black, which means you've now written it to the flight controller. Now the next one we're going to go over, as we've obviously already done RC, we're going to go to gains. Now what gains are is how stable and how reactive the model is to your input control. Now what I've done is I've kind of sort of gleaned the internet and databases for the best gains. So this set of gains that I'm going to program in just now are the ones that we use on the 450. They work quite well on the 550 as well, but they're simply a starting point, and you can mess about with these gains to get the model to fly exactly how you want it. But the gains, the way that they work is your basic gains, that's the top ones along here, that's all your different directions. So pitching basically means when the model's flying, if the red legs are the front, pitching is forward and backwards, rolling is obviously sideways, yaw is the twisting action, and then vertical is actually up and down. So the basic gains is how stable it is when it's hovering, when you are not controlling it. Now it doesn't necessarily mean the higher the gain, the better it will fly, because sometimes we can become a bit too locked on and a little bit too sensitive, and you can get a lot of wobble problems. Also, another one to watch out for is if you have a high basic gain, your attitude gain tends to be a bit lower. They almost balance each other like a sort of seesaw. So the gains I'm going to put in just now, as I say, these are the ones that I've kind of gleaned on the net and building a lot of models and test flying them. These are the ones I feel are a very good starting point. So there's one, oops, get that wrong, it's 165 for pitch, 165 for roll, then 150, then 150, and then your attitude gains. Now the attitude gains, what they're for is how the model reacts to your actual input on the controller. So I have these down at 100. These are very good for starting. If you're new to it, you don't want to be over controlling it. They're also very good for doing aerial photography. Now, as you see, they're all red, so we've put them all in. I'm going to press return, and then they all go black, and that's them written in. Now, you'll also notice these little drop down here. This is a little bit of an advanced setting. What this is if you want to sort of muck about with your gains, a handy way to do it is, you can imagine it would be very awkward to, every time you made a gain, you'd have to land the model, plug into your computer, make an adjustment, fly it, land it, plug into your computer. So what these are remote gain adjustments. So for example, your X1 channel on your radio, which as you know is a trimmer here. Now this could be like a trimmer knob on another aftermarket radio. And what you can do is you can actually assign a channel to basically act as a gain adjustment. So as you can see there, I'm now moving the lever and see the gains moving. Now they're moving a huge amount. You should actually, you should only move your gains by about 10% at a time. So the idea is as you fly, you can adjust the gain, get it exactly where you want it, and then basically lock it down. And you can do that on both your remote gains, so you would just basically do all these down at say 1, for example. So you do all your pitch and roll first, then go and do your yaw vertical, and then do your attitude gains. And then when you're happy where they are, you just inhibit those controls. So I'm going to just put that back to 165, because that is pretty much where I set all mine up, and they work pretty damn well. Okay, now we've covered all the basic stuff. This will actually get your model pretty much flying without any problems at all. Now the next tab we're going to go to is the Advanced tab. Now the first one, Motor, this is actually fairly explanatory. What this does is you can actually manually set how fast the motors are going to idle at. So you've got that one, and then Motor Cutoff is normally when you land your model and the motors are still idling because the stick's in the center, normally you would bring the stick all the way back, hold for a few seconds, and it would cut off. So basically you have the intelligent one, which is what I recommend it to do, or you can have that as immediate. But normally just pretty much leave that tab as is. You don't really need to change that. Next tab along is your Failsafe. Now this is if you lose communication with your model and it goes into a sort of fail-safe scenario, you can tell it how it's going to come home. So normally you would want it to come home. So that's your come home method there, go home and landing. So if the model is at lower than 20 meters, it will actually rise up 20 meters, just in case there's any obstacles, fly home, pause for a bit, and then come in and land. Or if it's above 20 meters, it will simply return home, pause, and then come in to land. Alternatively, you can have the straight landing. So if it goes into failsafe, it will pause just in case it's going to pick the signal back up, and it will land straight away. Now if your model were to do this and you were over say a body of water, simply by toggling the GPS button you can actually break it out of fail-safe mode and bring it home if you want. But the best type to have is actually the go home one, because the chances are you might have actually lost sight of it, and that's why you're initiating a fail-safe by basically turning off the transmitter, and that will initiate the fail-safe. Okay, next one is IOC, that is Intelligent Orientation Control. Basically what that is if you have it in the, obviously you always fly with it in the off position, that's your orientation control switch there. So top is off. Now the first click down, that is what we call course lock. Now what a course lock does is, the idea being is, no matter what way round your quadcopter is, normally the way you would have it is if I push the stick forward, the model would fly forward. Now if the model was facing sideways and I push the stick forward, the model's going to go that way, but in relation to you that is actually sideways. So with course lock on, regardless of the orientation of your model, if you do forward, the model will fly forward away from you. So if it's pointing towards you, you can actually pull the stick back and it will still come home to you. Next one down you've got is home lock, and what that is this is a handy one if you fly too far away and you get disorientated, you can't see the light at the back, you don't know what way it's facing, regardless of the direction it's facing, pull the stick back and it will simply fly home. So great for basically getting it in close to yourself, and then once you know what way round it is, you can flick off the course lock and then regain control. Now, to initiate that, you need to just check the wee button in the corner there, because it's actually disabled, just in case you accidentally flick it on. So click on the orientation control checkbox there, and now when I flick the switch, you'll see the dark cursor there now moving. So you've got home lock, bring it home, course lock, regardless of direction, you can just basically push it around the sky, and then of course in the off position. So that's your intelligent orientation control. Okay, next one along is a gimbal control. What this is, originally it was really developed for using servo gimbals, which we don't really use now. It's all brushless gimbals, but it is actually handy if you're ever fitting any Chinese aftermarket gimbals which have their own flight control, their own IMU controller. This is what keeps the gimbal level, but you want control over the actual tilt of the model. This is actually a handy feature to have. I'm not going to go into detail because if you check out the rest of the multi-rotor channel, there's a video on fitting a cheap Chinese gimbal. If you watch that now, it's getting fitted to a Phantom, but it pretty much uses exactly the same interface. It'll explain all about how to do that, because it's quite a lengthy setup, so I don't want to kind of make this video longer than it needs to be. Your next one down is voltage. Now what this is when you will, the model will know how low the voltage is and when it's going to initiate its, first of all, warning you, and then initiate basically a return to home failsafe. Now, what I've done again, I've done an awful lot of practicing on this, and what I've done is I've come up with some voltage cutoffs. Again, it is a starting point. Lots of people have their own specific voltage cutoffs. Some people prefer not to even use the voltage cutoff at all and fly it on a timer, but I prefer, if I'm supplying a model to a customer, prefer to supply it with at least some voltage cutoffs that I feel in most builds that I've done tend to be a good ballpark figure. So the ones I am going to put in are the ones that I recommend. So you can certainly copy them, see how it goes on, and change them if you want to. So the first one is 10.50, and we have a loss of 0.20, which gives you 10.30. Again, just press return, lock that one in. Now the first level protection, what that does is simply flashes the indicator status light at the back. You'll start getting a red flashing light, basically warning you to that you should really think about heading home. Now the next one down is the second level protection. This is the one where it will go into failsafe. Now I did say earlier it was a return to home failsafe. It's not, it's actually a landing failsafe. So wherever it is, it will want to land. As I say, if it's over water or you don't want to land there, toggle the GPS switch, or even actually use the throttle stick all the way forward will actually break it out of the failsafe. But remember, you've got the battery at its minimum, and you'll wreck the battery if you discharge it too low. So these values I set at 10.20, and again a loss of 0.20 equals that. Again, return it, and that's that bobbed in. Another thing you need to do as well, depending on how many cells you're running. Now these settings are for 3 cell, not 4 cell, as I generally build all my models on 3 cell. If you're running 4 cell, what you can do is you can take the figures I've got and you basically divide them and work out what the extra cell would be. So you can drop down, you've got all your various cell types, but normally in my multi-rotors it's either 3 or 4 cell, and this is this one. Another little one you've got here is basically a battery calibration there, and it just helps calibrate the battery's voltage, the actual voltage to what it's reading. And that's that for the battery one. Just before I wrap up on the battery warning, what I was saying about using these as a starting point, the way that you check if you're flattening your battery too much, the sort of rule of thumb is you shouldn't take more than 20, so you shouldn't take out more than 80% of your battery. So whatever your battery capacity is, you should at least leave 20% still in the model when it lands. Now the way that you can recheck this, you can use a battery analyzer. There's lots of battery checkers on the market. You can check it that way, but the best way is actually when you put it back onto your multi-charger and recharge it, generally your multi-charger will actually tell you how many milliamps are going back into the battery. So you can generally work out from there the capacity that you're putting back in, and you can get a bit of a rough idea how much you've actually taken out and work it out from there. Now, that's covered all the advanced tabs, so the next one along the top is we're going to do tools. Now the tools one is a handy little one. The first one actually is the IMU, so this is the compass status. So you can check if you've got values here. They should generally all sit around about this sort of, 0 point, not usually go much more than that. So if you saw any crazy figures in here, you could probably sort of think, there seems to be something up here. But the main reason you come in here is to actually check the status of your compass. So you just click on that. Now normally it will come up in here and say no need for calibration procedure, but if it did come up, all you have to do is just tick on basic calibration. So it's basically telling you to keep the model flat as possible and don't move it. Click yes, and then that's it, calibrating, and then that's you pretty much good to go. So once you calibrate it, you would just check status, and it should come up with this and say that it's no need to do it. Now this is just a sort of overall calibration, so you still have to do your compass dance when you go out. The old toggle the switch up and down. It's basically 6 to 10 times. Your LED indicator on the model will go solid yellow, and then you do your rotation, a flat rotation 360, then on its nose rotation 360, and that'll be your compass calibrated. So if you ever go to visit a new location, ideally you should always do that. Now you've also got a couple other tabs in here as well. As there's an export parameters one. This is actually quite handy. If you're setting up your model, you can actually export all these settings onto a file, just in case for whatever reason, I don't know, you maybe had to send your flight controller back and then it had a firmware update and all the settings got wiped. You can basically export them and then basically re-import them. There's also a restore to default settings, but this really does wipe it down to nothing, so you'd have to go through the whole setup all over again. Now lastly, there is an upgrade tab. Now, to be honest with you, there hasn't been an upgrade on the Naza Lite for quite a while, so the chances are it'll say firmware 1, latest version 1, so very unlikely you'll ever have to check that one out. So once you're done there, you can come back to the view window, and now all these parts have all now been filled in. So you've got things like your location for your compass, and you've got for your GPS, you've got all your gains, basic and attitude gains, obviously your control indicators, you've calibrated your radio, etc. You've got all orientation control on, gimbal switch off, voltages, etc. Your failsafe type, the motor idle speed, basically everything you've got all set up. So I hope you find this video helpful. It's very handy if you followed our video for the build and you just want to do the flight control setup. Now, just one thing I want to point out that's changed from when we built the E300 F450, which obviously applies to the F550 as well. The flight control, the Naza Lite flight control, is very slightly different. It used to have an all-in-one power unit and LED module. It was like a little black bit, and you will have seen me mounting it at the back here. Now they've made a small change on the flight controllers. They now have a separate LED unit like they have on the Naza 2, and then in the side there, as you can see, you've got actually a separate PMU. Now it's not a proper PMU with a CAN bus, sadly. That would have been a great idea. It's basically just a separate power unit. I don't really know why they've done that, is because it really doesn't serve any more purpose. The old one was quite handy because it combined the whole two units into one, so they've basically split it into two. Maybe there'll be something coming in the future, I don't know, but that's how they've done it. So that might look slightly different. And if you've got the Naza V2, pretty much works in exactly the same way. The assistant software looks very similar. The Naza V2's got a little bit more going on. There's a little bit more diagnostics in the compass and setting up of the motor, so it's a little bit easier to use, but pretty much laid out in exactly the same way.